soft wind. A vast white desert stretches beyond the horizon. The sun burns overhead. No oil rigs. No smoke. No fire. This place looks empty. But beneath this cracked salt skin lies one of the most powerful substances ever discovered by humankind. It does not roar like oil. It does not glow like uranium. It does not explode like coal-fed fire. It moves silently, invisibly, through your phone, your laptop, your car, your future. This is lithium. A metal born in the infancy of the universe, hidden for millions of years in stone and salt, now driving the greatest technological transformation since electricity itself. This is the geological story of lithium, its birth, its discovery, its extraction, and how the Earth's deepest processes now power modern civilization. Before continents, before oceans, before life, lithium was forged in the first few minutes after the Big Bang. As the universe cooled from unimaginable heat, only the lightest elements could form: hydrogen, helium, and traces of lithium. Unlike iron or gold, lithium is fragile. Inside stars, it is easily destroyed. That makes lithium rare. And that rarity is what makes it valuable. When Earth formed 4.5 billion years ago, lithium became locked inside its rocks, scattered, diluted, almost invisible. For most of human history, we never noticed it. Lithium does not form veins like gold. It does not pool like oil. It concentrates slowly, patiently, through some of the most extreme geological processes on Earth. Deep beneath ancient mountain belts, magma cools slowly. As it cools, common elements crystallize first. But lithium, light, mobile, restless, is pushed into the final molten remnants. These remnants form pegmatites, coarse-grained igneous rocks with crystals the size of fists, sometimes the size of doors. Here, lithium locks itself into minerals like spodumene, petalite, lepidolite. This process takes millions of years. Today, these lithium-rich pegmatites are mined in Australia, Canada, Zimbabwe. They are the hardened fingerprints of ancient magma chambers. In other places, lithium follows a different path. Rain falls on volcanic mountains. Water seeps through rock. Atom by atom, it dissolves lithium. The water flows downward into closed desert basins with no outlet. The sun does the rest. Over millions of years, water evaporates, but lithium stays. Layer upon layer, drop by drop, until entire underground reservoirs become saturated with lithium-rich brine. These form the world's greatest lithium reserves. Chile, Argentina, Bolivia, the Lithium Triangle. Here, geology, climate, and time align perfectly. In some regions, lithium becomes trapped in altered volcanic ash, fine sediments transformed by heat and hydrothermal fluids. These deposits are younger, harder to process, but may define the future of lithium supply. The Earth is still creating lithium reservoirs. For centuries, lithium remained invisible. It has no color, no smell, no shine in raw form. Its discovery required science. 1817, a quiet discovery. Swedish chemist Johann August Arfwedson noticed something strange in a mineral sample. It behaved like no known element. He named it lithose, from the Greek word for stone. Lithium was officially born, but still, nobody cared. There was no engine for it. No market. No need. That would change. Today, lithium exploration is a high-tech race. Geologists search deserts and mountains using satellite imagery, geochemical sampling, geophysics, deep drilling. They look for one thing: concentration. Because lithium is everywhere, but only rarely is it enough. Extracting lithium is not simple mining. It is a balance between chemistry, energy, water, and time. Brine extraction. In salt deserts, lithium is pumped from underground aquifers. The brine flows into vast evaporation ponds, artificial lakes painted turquoise, yellow, green. The sun works for months, sometimes years. Water evaporates. Lithium concentrates. Eventually, the brine is processed into lithium carbonate, lithium hydroxide. This method is cheap, but thirsty. It competes with fragile desert ecosystems for water. Hard rock mining, the fast method. In pegmatite regions, lithium is mined like traditional rock. Ore is blasted, crushed, heated, and chemically altered. Spodumene is transformed into usable lithium compounds. This method is faster, but energy intensive. Both methods scar the land. Both fuel the future. Long before batteries, humans encountered lithium unknowingly. Natural springs rich in lithium salts were prized in ancient Greece, Rome, Asia. People believed these waters calmed the mind. They were right. In the 19th century, lithium was prescribed for gout, melancholy, mental illness. Even today, lithium remains one of the most effective treatments for bipolar disorder. But its true power had not yet been unlocked. The electric revolution. The problem of electricity was never generation. It was storage. Lithium solved that. Why lithium? It is the lightest metal. It stores enormous energy. Its ions move easily. It can be recharged thousands of times. No other element combines these traits. How a lithium battery works. Inside every lithium-ion battery, an anode, usually graphite. A cathode, lithium metal oxides. An electrolyte, a separator. When charging, lithium ions move from cathode to anode. When discharging, they flow back, releasing electricity. No flame. No explosion, that just controlled atomic movement. Lithium and automobiles. Electric vehicles changed everything. A single EV battery contains 8 to 15 kilograms of lithium. Entire supply chains now depend on it. Lithium powers cars, buses, trains, drones, entire cities. It is the backbone of decarbonization, but also a new geopolitical weapon. Lithium is clean in use, but not clean in extraction. Environmental impact, water depletion, habitat loss, chemical contamination, geopolitical tension, supply monopolies, resource nationalism, strategic stockpiling. Lithium is the new oil, but without pipelines. Lithium takes millions of years to form. Humanity may exhaust reserves in decades. From magma chambers to desert brines to silent electric motors. This is geology compressed into modern time. Beneath your feet lies the past. Inside your pocket lies the future. Lithium is not just a metal. It is the bridge between Earth's deep time and humanity's next chapter. And like all geological gifts, it reminds us, the planet always pays the price. If you found this documentary educational or inspiring, like the video, share it, and subscribe to the Geologic Lens. Because every rock has a story, and the Earth is still speaking.